Assalamu alaikum students. To explain, I myself Aamina Patni. To explain it to you all, how the ray diagrams can be drawn for the concave mirror, I have made this video. Okay. Now, girls, before starting with the ray diagrams of light, let us understand and recall the few concepts, and then we'll go for the ray diagrams. Okay. Now you can see over here concave mirror and convex mirror. Okay, the difference between concave mirror and convex mirror. Concave mirror, you have both concave mirror and convex mirror are the parts of spherical mirror, correct? And here you can see for concave mirror, this is the side which is coated with the silver paint, yes, and the inside part is the reflecting surface. Okay, for convex mirror also you can see over here the inside part is coated with the silver paint, okay, and here the outside part is the reflecting surface, okay, where the light rays will fall on it and you will get your image. Here we have the inside part as the reflecting surface. The light rays will fall on this inside part because this side is coated, okay. In lens, what happens? The lens which we use in spectacles, okay, the light rays passes through the lens because there is no coating, okay. Here in mirror, concave mirror and convex mirror, we have coating on one side, okay. Then here you can see, before drawing the ray diagram, we should be knowing what do you mean by C, what do you mean by principal axis, what do you mean by F, okay, what do you mean by P, okay. P stands for pole, okay. Point C stands for center of curvature. Point F stands for principal focus, okay. Now here I have drawn, this is which type of mirror I have drawn? I have drawn the concave mirror. So I have drawn the part of the concave mirror, correct? The coating was on this side, yes, okay. And the inside part is the reflecting surface. The inside part is the reflecting surface. If you take the center of the part of this reflecting surface, then that point is considered to be as pole. I repeat, if we take if we take the center of this part of the reflecting surface of concave mirror, then this center of it is called as pole. The line passing through the pole and this C, center of curvature, that line is called as principal axis. The line which passes through the pole P and center of curvature is called as principal axis. So you can see this line is called as principal axis. What is center of curvature? Point C. Why it is called as center of curvature? Because if we make this part of this mirror as a spherical mirror, if I make a circle like this way, if we make a part of the spherical mirror, then the circle has a center, okay. Always the circle has some center, and this also has got one center, and that is called as a center of curvature. If I make this part of the concave mirror a spherical one, okay, it will have some center, yes, one center it has, and so therefore this is also considered as, we consider it as a center of curvature. What do you mean by F, capital F, principal focus? What do you mean by this capital F? Why it is called as principal focus? And principal focus is exactly in between the center of curvature and pole. Okay, why this is called as principal focus? Any incident rays of light, you can see I have drawn here two incident rays of light. This middle line is principal axis. I have drawn two incident rays of light, this one and this one. When two incident rays of light which are parallel, number of rays of incident rays of light, it is not only that we can draw only two. Any incident ray of light which is parallel to the principal axis falls on this reflecting surface of the concave mirror, it will reflect back and pass through a special point, and that point is called as principal focus. You can see over here this incident ray of light which is parallel to the principal axis, it is falling over here on this reflecting surface. After falling over here, it strikes the reflecting surface of the concave mirror, and where it is going, it is passing through this point, and this point therefore is called as principal focus. You can see over here, this also incident ray of light which is parallel to principal axis, it is passing it is falling on the reflecting surface over here, it strikes over here and reflects back, and where it is going through this special point. So this special point is called as principal focus. Okay, so therefore this is principal focus. It is always exactly in between point C and point P, center of curvature and pole. Okay, and what do you mean by focal length? So remember this, the distance between the focus and pole is called as focal length, which is indicated by small f. The distance between principal focus and pole is considered to be the focal length, that is small f. Or you can say the distance between the center of curvature and principal focus. This is also the same. If this distance is 6 centimeter, this will be 3 centimeter, 3 centimeter. They both are equal, and each is considered to be the focal length. Okay, so this is important to understand, and we should be knowing the three rules to draw the ray diagrams. Okay, so these three rules states, the first rule states that any incident rays of light which is parallel to the principal axis, yes, this is our principal axis, the middle line is the principal axis. Any incident rays of light which is parallel to the principal axis, when it strikes the reflecting surface of the concave mirror, where it goes, it will pass through the principal focus. Okay, it will strike over here and it will pass through where? It will pass through principal focus. So the first rule is always, remember this, that whenever the incident rays of light parallel to principal axis falls on the reflecting surface, it will pass through focus. The second rule, any incident ray of light which passes through capital F, focus. Okay, it is vice versa of the first rule. Any incident ray of light which is passing through the capital F point, capital F, that is through the focus, it will strike the reflecting surface and it will go where? It will go parallel. Okay, so it will go parallel like this way. The second rule states that any incident ray of light which is passing through the capital F point focus, it will strike the surface, reflecting surface of the concave mirror, and it will travel parallel to the principal axis. Okay, so this is your principal axis. The third rule states, this is rule number 3. Any incident ray of light which is passing through the center of curvature, any incident ray of light which is passing through this point center of curvature, when it falls over here on the reflecting surface of the concave mirror, where it will go? It will retrace the same path. It will go back like this way. It will retrace the same path. It will travel back the same path it goes. So any incident ray of light which is passing through center of curvature, it travels the same path. It retraces the same path. So these are the three rules. Okay, any rays which are parallel to principal axis falls on the reflecting surface, it passes through focus. Any incident ray of light which passes through focus, it will go parallel to principal axis. And any incident ray of light which passes through center of curvature, it will retrace the same path. So these are the three rules. So next time, in my next video, I will show you how to draw the ray diagrams. We have six ray diagrams of concave mirror. So we will start with the 3 ray diagrams of concave mirror. Okay, thank you so much. Assalamu alaikum.